Alright, so last time we looked at the reaction mechanism between sodium hydroxide and hydrochloric acid to produce water and sodium chloride. Now we're going to look at some examples. So the first one that we're looking at is sodium hydroxide here on the left, and then we have acetic acid. So let's see what happens. So remember, first we have to look at where are the electrons coming from. So that's what we're going to do first. So if we look at sodium hydroxide, the hydroxide has a negative charge. So that's where the electrons are going to be coming from. And right here, the acetic acid has a proton to donate. So we have our acetic acid here. And this is going to be the proton that gets donated to the hydroxide to form water. So I'm going to first show the electron movement, and I'm going to draw these two electrons blue so that I can show you later where they're going. So it's best also to show this hydrogen separately as a hydrogen with a bond to the oxygen so that you can show the bond being broken. So we show the electron movement of the lone pair of the hydroxide on the oxygen going towards the hydrogen, and then we have to show this bond being broken. So these two electrons are now going to go towards the oxygen. Now that's going to form an acetate molecule. And now that oxygen on the left is going to have a negative charge. So I'm going to draw these two electrons again, and then I'm going to put a negative charge on it. Okay, so now the countercation that we had is going to go next to it. So it's a spectator ion. It's not doing anything there, and except spectating. All right, so now what happened to the hydroxide? Well, now this hydrogen over here, we have just made a bond to this hydroxide here. So I'm going to just put it here for now, and then I'm going to duplicate this, and then now that's the product that we're forming. And then I'm going to delete the hydrogen here on the left side of the equation. That's a negative sign, not a positive sign. Okay, so now on the product side, now we just made water. And we still need to draw the bond that we just made, so that's this one right here. So we have water and sodium acetate that form. So let's look at another example. So we have here methylamine and hydrochloric acid. Again, where are the electrons coming from? So the electrons here are going to come from the lone pair of the nitrogen. And where is my proton coming from? It's going to come from the the hydrochloric acid. So I'm just going to draw my electrons red again there. Again, same thing, flow of electrons. Electrons are coming here from the nitrogen, and they're going to go towards the hydrogen and then break off the hydrogen chlorine bond. All right, same thing as we did last time. We're going to show chloride. Chloride just formed, so I'm going to erase those, and then I'm going to write a lone pair. So lone pair is still there, it's just I wanted to draw a little bit better. And okay, so where's our cation? Well, in this case, our cation is going to be our ammonium. So this hydrogen here is making a bond. That's what this arrow is showing. And it's making a bond with methylamine. So that's going to make methylammonium, I believe that it's called. And I'm going to erase my hydrogen here. And we just made a bond between nitrogen and a hydrogen. So now we have, but let's draw that a little better. So I'm going to move this hydrogen on top here, and we just made a bond to it. And the electrons came from the nitrogen lone pairs. Now that nitrogen has 4 bonds now, so it should have a positive charge. And we don't need a plus sign in between because these are actually an ion pair, methyl ammonium chloride. All right, so let's look at one last example. Here we have N-butyl lithium and we have acetone. So where are the electrons? Well, usually, I don't know, it's a good hint that if you have a cation here, like lithium, it's +1. There's going to be a negative charge somewhere. So the negative charge here is on the carbon. So we can just erase that line and draw a negative charge there because that carbon is a carbanion. All right. So, but where is our hydrogen? Well, let's draw the hydrogens that we have available here. We have a hydrogen here, here, and here. And we also have hydrogen here, here, and here. But they're all the same. They're all identical, equivalent is the proper terminology. So I'm going to draw one of those hydrogens, and then we're going to show the acid-base mechanism. And I'm going to put my 2 red electrons there on the carbon-hydrogen bond. So now the carbanion is going to attack the hydrogen, and then we're going to break the carbon-hydrogen bond. Now you could show this as like a resonance. So like after you deprotonate, you show resonance. But I just want to keep it as 1 and then 2 arrow mechanism. So I'm just going to show the 2 electrons going towards the carbon. So 2 electrons going towards the carbon. All right, so let's see what that looks like on the product side. So I'm just going to copy this molecule that forms. So we form what they call an enolate. So we got an enolate on the right side. So we form another carbanion. This one's more stable because it has resonance with the carbonyl group. And our lithium is going to be a spectator ion, so we draw it next to it. And we also have formed butane. So this hydrogen over here just made a bond with the carbon, so I'm just going to draw it over here next to it. And that has formed butane. So we have butane now. And I'll just erase this hydrogen because it's not useful anymore. So those are 3 example acid-base arrow pushing mechanisms.